Hello everyone. Before starting the lesson, try this warm-up. Complete the table of values for f of x equals negative 5x squared plus 30x plus 35. Here's the table of values. Plug in your values of x and calculate the corresponding output for the function. Pause the video and try this on your own. Here are the numbers. And just as an example, if you had trouble with this, when x is negative 2, that's the input to the function. So we're finding f of negative 2. We're replacing x with negative 2 everywhere we see it. Now we just evaluate by following the order of operations, BEDMAS. Exponents come first, then multiplying, and then adding and subtracting. So if you had trouble with any of these and you can't figure out what your error was, you should pause the video and ask for help before you move on to the lesson. We're beginning our unit on quadratic functions, so this lesson is just an intro to that. We're going to graph quadratic functions using transformations. We're going to determine the vertex, the y-intercept, the x-intercepts, the axis of symmetry, and direction of opening for a parabola when given the graph or equation of its quadratic function. So first, let's get some terminology written down so that we are using a common language when we're talking about these quadratic functions. The shape of a quadratic function on a graph is a parabola. Now, every parabola is going to have some major points. That's what I'm going to call them, and they have different names. The vertex is the highest point, or it could be the lowest point if your parabola opens the other way. And the y-intercept is the point where your parabola crosses the y-axis. Now your x-intercepts are where your parabola crosses the x-axis, and often we call them zeros as well as x-intercepts, but it means really the same thing. Now every parabola has an axis of symmetry. This is a vertical line that goes through your vertex, and we call it an axis of symmetry because it's the line over which the parabola is symmetrical. It's a mirror image on either side. So we can think of this as an example. The x-intercept over here is the same distance away from the axis of symmetry as the other x-intercept. They're both the same distance away from the axis of symmetry. And that is actually a key idea that you should keep in the back of your mind as we talk about quadratic functions. So the big picture here is that different major points have different names, and we need to be familiar with where they are located and what they mean. The other thing you should be familiar with is the direction of opening. So when I say the parabola opens up or it opens down, you need to know what that means. Now I've drawn on the screen here what shape or what direction the opening goes. If it opens up, it's like a U shape, U for up. And if the parabola opens down, the graph would look like this. A frown. Down, frown, U, up. That's how you can remember up versus down. Now there's three different ways of writing the equation for a quadratic function. There's the vertex form, the standard form, and the factored form. Now on your screen, I'm showing you an example of one quadratic function. I've just written its equation in three different ways. If I graph each of these equations, I will get the exact same graph because they are representing the same function. Now, doesn't matter which form of the equation I use, when I graph it, I will get a graph that looks like this, and I can find the coordinates of these major points. Now, the point of this screen is to show you the relationship between the numbers in the equations and the coordinates of these major points. In the vertex form, if you look at these numbers in the vertex form equation, they tell you the location of your vertex. Watch out here, it says x minus 3. The x coordinate is positive 3. Plus 80, still plus 80. Watch out for that. but if you know those two numbers, that tells you where the vertex is. Likewise, if you look at the standard form equation, the constant term tells you where the y-intercept is. And the factored form equation shows you where the x-intercepts are. Just watch out again. It says x plus 1, but the x-intercept is minus 1. X minus 7, but the x-intercept is positive 7. So just watch out for that, a relationship between the signs in the equation and the signs in the coordinates. But here you have it. If you have vertex form, you know where the vertex is. If you have standard form, you know where the y-intercept is. And if you have the factored form, you know where the x-intercepts are. Now, if you happen to know where the vertex is, you actually do know the equation of your axis of symmetry as well. Or if you know where your x-intercepts are, and because you know the axis of symmetry is going to be exactly halfway between those values, well, you can figure out what's the distance between your x-intercepts, what's half that distance. That tells you where your axis of symmetry is. So try to be comfortable with this idea that the different forms of the equation tell you about different points on the graph, and then you can find out where that axis of symmetry is, and that'll come in handy later. Now, there's different forms of a quadratic function. And if you only know one of them, you might want to turn it into one of the other forms to get more information about the graph. So we're going to start looking at that. In this example, we're going to express the function in standard form. Right now, we have it written in vertex form. So how do we change it to standard form? Well, we have to expand and simplify. Now, you've already done some practice in the last unit on expanding and simplifying, so why don't you pause the video, expand and simplify this function, and you'll get what the function is in standard form. So pause the video, try this, and then check back in to see how you do. Here's what I got. Remember, squaring means multiplying by itself. When you expand the brackets, each of these gets multiplied by each of these. I have like terms, so I simplify them. Each of these terms in the brackets gets multiplied by the number in front. And then again, I have like terms that I simplify. So if you didn't get this and you're not sure where your error is, please pause the video and get some help before you move on to the next example. In this example, we're going to graph the function -3 times x plus 2 squared plus 3. Now, we have done a little bit of practice with this already in the course. You need to figure out what your parent function is, figure out what all the transformations are, and then you can plot that on the grid. I also have extra information that we're looking for. What is the direction of opening? Is it up or down? What are the coordinates of the vertex, the y-intercept, the x-intercepts? What's the equation of the axis of symmetry? And we'll even throw this in, domain and range. See if you can remember all that. So you can pause the video and try this. I will take this up piece by piece so that you don't have to just look at everything all at once if you just need a little bit of help to get started. So pause the video, see what you can do, and then you can check back in. Remember to start with what the parent function is and plot some points from the parent function. Next, we have to find out what are all the transformations that are being applied. We have a vertical reflection, a vertical stretch times 3, translated left 2 units, and up 3 units. So we have to apply each of those 4 transformations to each point on our parent function. And when I do that, I get my points transformed into these new locations, which I've indicated in blue, and draw a curve through your points. as smooth as you can, indicate that it keeps going with arrows. So there's the graph of g of x. Now that we have the graph, figure out the direction of opening, the location of the vertex, y-intercept, x-intercepts, and the equation of the axis of symmetry. The graph opens down like a frown. The vertex is located here with coordinates -2, 3. The y-intercept is right here at coordinates 0, -9. The x-intercepts here and here, -1, 0, and -3, 0. The axis of symmetry, well, because we know the vertex, we know the axis of symmetry. The x-coordinate is -2, therefore x equals -2 is the axis of symmetry equation. All right, next, domain and range. X is an element of the real numbers, that's the domain. I know this because the graph will keep getting wider and wider and wider. X can be any number to the right, any number to the left, and anything in between. There's no restrictions on X. There is a restriction on Y though. It has a maximum value of 3. So Y must be less than or equal to 3. As long as that restriction is met, Y can be any real number. So hopefully all this is coming back to you now. If you're having troubles with any of the stuff from this example, you should pause and ask for help on this or clarification before you move on to the next example. All right, I want to show you how to determine the y-intercept without graphing. Now it's kind of easy if you already have standard form, you already know what the y-intercept should be. But if you don't have the standard form equation, how do you know where the y-intercept is? Well, you could expand and simplify to turn this into standard form, but that's more work than needs to be done. Think about the y-intercept. It's where the function crosses the y-axis. Well, what's the value of x at that point? Always 0. So if we substitute 0 for x and calculate, we get what y is at that point, and that gives us the y-intercept. So if I find the value of the function when x is 0, all I have to do is calculation. I don't have to do any expanding and simplifying, just follow BEDMAS, and I end up with my y-intercepts. But what if I want to find the x-intercepts without graphing? Now that's a little bit different. If you think about a graph, your x-intercepts are located on the x-axis when y is equal to 0. So substitute 0 for the output of your function. Now you can factor the expression. So pause the video and try to factor these and see how you do. Well, here's what we get when we factor. If you have an issue with this, you can pause and ask for some help before we move on. But once you've factored, you can actually solve an equation like this. If this factor multiplied by this factor equals 0, well, either this equals 0 or this equals 0. That's called the zero product property. It's like this. I know that 5 times 0 is 0. I know that 0 times 4 is 0. Any number times 0 gets an answer of 0. So if I'm multiplying two things and the answer is 0, well, either this is 0 or this is 0, or they're both 0. So it's the same here. Either x minus 2 is equal to 0 or x minus 3 is equal to 0. Now, solve these separately. If x minus 2 equals 0, what does x have to be? If x minus 3 equals 0, what does x have to be? Well, in the first case, x would have to equal 2, and in the second case, x would have to equal 3. So now that we figured out what x would have to be, we have now figured out what the x-intercepts are, 2, 0, and 3, 0. Now you've already factored the second example. Why don't you pause the video and see if you can figure out what the x-intercepts would be for this one. Well, here it is. The x-intercepts are -1/3, 0, and -2, 0. If you had any trouble with this, pause the video, ask for help before you move on. Now, in this last example, I want you to determine the x-intercepts and axis of symmetry without graphing. In the previous example, we found the x-intercepts, so this question starts the same, but then we're also trying to find the axis of symmetry. So pause the video and see if you can find the x-intercepts just like you did in the previous example. Do that first. So remember, the function is equal to 0 at the x-intercepts. We factor. I noticed there was a greatest common factor of 2, and this is a difference of squares. Once I've factored it, I notice that either 2x plus 5 equals 0 or 2x minus 5 equals 0. And I get my x-intercepts from those answers. Now, let's find the axis of symmetry without graphing. Remember, the axis of symmetry is the line of symmetry, which means it's a mirror image on either side. So if we know where the x-intercepts are, we also know that the axis of symmetry is halfway between those x-intercepts. It's going to be in the exact middle. So what's in the middle of -5/2 and +5/2? Well, it's 0. 0 is halfway between, so the axis of symmetry has the equation x equals 0. If you're not sure how to find halfway between two numbers, you can always just take the average of the two numbers. That will always work too. And now it's time to practice. We've talked about terminology associated with the graphs of quadratic functions, and we've done a little bit of algebra to find some major points like the vertex, the x-intercepts, and the y-intercept. So now it's time to practice all that, and if you run into any issues, please reach out for help.